I'm Julien Grall. I've been working on Xen for the past 4 years. I'm maintaining with Stefano Stabilini the ARM port of Xen. So Xen is a type 1 hypervisor, so it means it's running directly on top of the hardware. We support different architectures such as x86 on 64-bit, on the ARMv7 and ARMv8 when virtualization is enabled. So the main difference between, so what is a type 1 hypervisor? So there is two types of hypervisor mostly, type 1 and type 2. The type 1 hypervisor will directly run on top of the hardware, and then you have each guest on top of it with the applications. In case of the type 2 hypervisor, you will first start your Windows or your Linux, and then you will have the hypervisor on top of it. For example, VirtualBox is one of the main type 2 hypervisor. And then you will have the guest after that. So in the case of Xen, the architecture, so as I said, Xen is directly running on the hardware. Xen itself is very small, so we don't support all the driver inside. So we expect one domain which will be created at the beginning, DOM0, which will own most of the hardware like PCI, network card, etc. It will be also the control domain, so when you want to create a new guest, the user space tools will be there, the tool stack, to go ask for the configuration, the disk, etc. After that, when you want, so you got multiple guests. Each guest will need the network, block, etc. What we use for block on the network is PV drivers. So PV drivers is a backend and frontend. The frontend is on the guest. The backend is on DOM0 on most of the case, and they will communicate to get the networks on the disk. So there is no emulation on the guest. So Xen has many different features, and some of them are very specific to Xen, like driver domain. I will go a bit further on the next slide. The second thing we can have is like different schedulers. So we got the main scheduler, Credit 2, and we have also real-time scheduler if you want to use in automotive or in contrast environment. We can also have different, have a pool of CPU, like for instance, you got many CPUs and you want different schedulers, so we can have a scheduler for a specific set of CPU on another scheduler, like a real-time for another set of CPU. You can also pin guests to a specific CPU if you want performance on avoiding the scheduler. One of also the main features that we are using is memory introspection. So the idea is to be able to watch what the guest is doing. So for instance, if having an antivirus and an operating system in a guest, the guest may be compromised by a malware, so you won't be able to, your antivirus may not work anymore. So what you may want to have is the antivirus in another VM, and this VM will watch what it's doing, access to the memory, access to system registers, and etc. And the last feature, which is fairly common to every hypervisor finally, is device pass-through. So being able to add PCI, to assign a PCI device to a guest, or to assign like a network card of your SOC to the guest. So in the case of driver domain, so what I mentioned on the first slide is most of PV drivers, most DOM0 is the main guest. So if DOM0 is crashing, everything is crashing. So in the case you want a bit more isolations, you may want to use driver domain. So the idea is to have a specific domain for a specific driver, like a specific device, like a disk driver domain. So this, if your driver is crashing for any reasons, you will just crash the driver domain. You won't crash DOM0 on all the platform. So this is adding isolations on your environments. Also, the idea is like you may want to have another operating system for your disk or for handling some device like QNX or anything else. And you can use a specific driver domain with that, with this device, on using backend and frontend for communicating. So we are also trying in general to have a really good security process to be transparent. So we explain every time there is a security issue, we have a security mailing list where they will deal with the person that reveals the security to see explaining what's the issue, what is the mitigations, and also defining when it will be released. So in the case of if you use that in big environments, you don't want having a zero-day security issue. So what we are trying to do is there is a bunch of people using Xen that are aware of the security a bit before the public, so they can. Sorry? Okay. So they can decide to patch, if possible, beforehand their use of Xen, and then we, when the security issue is disclosed, everything is working perfectly and there is no issue. And we also have stable trees, so we release them every 6 months or so. And we are all the previous releases are stable for a moment, so we do usually bug fix security issue. But after a couple of releases, we decide to not backporting bug fix, but we still continue to support security issue for 2 years. So if you are running not the latest version of Xen, you will still be secure. So this is the main part of the talk, virtualization on ARM. So the first thing is virtualization on ARM has been added on ARM v7, and there is support for ARM v8, so 32-bit and 64 bits. It provides a clean virtualization interface for timer, interrupt controller, on page tables. So the idea, if you have your set of device with the generic timer, the Gig v2 or Gig v3 MMU, and you have the I/O device on one side, and you have, so I didn't specify the first level of the trusted firmware, but you have basically 3 levels we care on Xen. So you have EL2, EL2 for the hypervisor, EL1 for the kernel, and EL0 for the user space. And to communicate between EL1 and EL2, you have the hypervisor call. So the architecture of Xen is fitting quite well in general of the ARM architecture. So the idea is you have EL2 with Xen handling the generic timer, the Gig v2 on the stage 2 MMU. And you have DOM0, which will handle all the other devices, like as I say, PCI, network card, etc. On the other side, you have any guest VM, which will communicate with Xen, with HVC, or maybe some share page. What we try to do is, so Xen on ARM has been added in 2012. Xen has been there since 2003. We started with x86, where there was no hardware virtualization, and this has been added. So we have got on x86 quite a legacy in general to support all the previous architecture. So what we decided with Xen on ARM is to get a cleaner port. So it's not like, we didn't take x86, what was done and put on ARM with the support. We just rework from everything. So there is no device emulations. We only support one kind of guest. In case of x86, we support 5 different guests. And we exploit as much as possible the virtualization support. So like I said, timer, generic Gig on MMU. And the last thing is if you want to add a support of a new OS, booting your OS as a guest on Xen, it's much easier. There is few things to add, like PV drivers. Otherwise, we use much of the boot path of as a Linux running on bare metal. So smaller ports, which means smaller code base. So this is a slug count of the previous release of Xen 4.7, which has been released in June. So as you can see, the ARM port is like around 25,000 lines of code. On the x86 port on the other side is above 100,000 lines of code. So it's very small. It's like 1/5 of the x86 port. That means 2 things. It's there is a small surface of attack, so less code means less bugs and less possibility to exploit anything. Second thing is we don't have any device emulation, which means we don't have QEMU, which is also I don't know the size of QEMU, but it's quite a lot of line of code less. And we are able also to, as I say, isolating, disaggregating the different domain to have drivers, specific drivers in specific domain, and also partitioning CPU and the memory. And so the next release of Xen will be in December, so we move to a 6-month release in December and in June. Most of the features that will be supported will be both for, so we care for both servers and embedded system. So there will be support of EFI on guest, on host supports, ACPI supports, so this, for both host and inside the guest. And we also support the different patch granularity like 64K, 16K, 4K. So most of the feature, we are close to the feature parity with x86. So all the main features are present. Few of them are missing, like such as PCI pass-through. And we are trying to add every release more support of new boards on new platforms. So if you want to add support of your socks, it's very easily, and most of the time you don't have much things to add, except the UART for debugging on the maybe CPU bring up if you don't use PSCI. If you want to contribute, if you want to use Xen, we have different ways to communicate and to have more information. So you have the user mailing list where you can ask questions about how to use Xen. It doesn't work, or I'm not sure what can be done. We also have a wiki where we explain how to build Xen for ARM, how to set up for specific boards. And we have a white paper explaining the architecture of Xen ARM and in general, on how to port an operating system to the guest. So we are always looking to have more people contributing in Xen, so we have many features. We are an open source project, so most of features are working on open source, many companies are working on it. So if you want to contribute on Xen, you can go on for patch sending on Xen Devel. And if you want to have a quick question or discussing with people, we'll usually hang out on Xen ARM and Xen Devel on Freenode. So, is there any questions? Yeah.
So does this mean Lenaro's getting back into Xen on ARM? I know for a while Lenaro pulled out of that.
So we are discussing with Lenaro about adding more resources in general. And ARM has a couple of engineers also working on Xen ARM.
Is it for more than just enterprise? Is it also for embedded type products as well?
Yes. I don't have the name, but I was in the developer summit a month ago in Toronto for Xen, and many people were interested to use Xen on automotive. I've heard that some people are making products for automotive and also industry. We've seen many people taking care of automotive in general. Any other questions? Last question. Thank you for listening.
We're going to go over LuaJIT status here in a little bit. Just please bear with me as I set up. Okay, that's not what I want. Perfect. All right, hello. My name is Ryan Arnold. I'm the Linaro Toolchain Working Group Engineering Manager. I'm going to go over the LuaJIT status for ARM64 port. This has been something we've been working on in conjunction with our friends at ARM, and as well as some business partners and members, and also some community members. The Lua Jetport porting effort did start in April, so we've been furiously working over the last 4 or 5 months on this port. All right, so first I want to just talk about what Lua is, so you have a bit of background, and then we'll go on to where the porting effort is. So Lua is an interpreted scripting language that's easily embedded into application engines. So you might ask, well, isn't this just something that video games use? And originally it was used by video games, but it's also a very effective embedded scripting language for web server front ends. So I'm not going to go through all the information on the slides. It's for your information. But this slide discusses how it's used in the Nginx web server, for instance. The interesting thing is that it allows the use of Lua coroutines to provide asynchronous yet non-blocking API access to network services. And the interesting thing about using a JIT is that JITs are faster than just straight interpreted scripting languages. And Lua itself has the FFI interface, which is the foreign function interface. I'll get into that just a little bit more in the next slide. So we're also seeing this showing up in software packet networking engines like Snab. So why LuaJIT specifically, or why is LuaJIT interesting? So just LuaJIT is a trace compiler, or a just-in-time trace compilation engine for the Lua language. Appendix A goes over exactly what a trace compilation engine does. I'm not going to get too much into it, other than to just say that it identifies a hotspot in code and compiles that code, and then future iterations of that hotspot are executed with the compiled code rather than in interpreted mode. So there's anecdotal information that says that LuaJIT itself outperforms other scripting languages like Python, Ruby, and interpreted Lua by about 10x, which is pretty impressive. And like I said, the FFI interface, it allows the invocation of high-performance C library functions from within Lua scripts. So you can see how this can be pretty powerful for a web server. It can script what it wants to do with Lua and then call out to a highly optimized library if it wants. So LuaJIT's support for AR64 has been noticeably lacking until recently. So the slide header is AR64, but you'll notice I reference ARM64 throughout. This is because the LuaJIT community refers to the 64-bit ARM v8 architecture as ARM64. So currently only, or previously only, interpreted mode worked for ARM64, whereas x86-64 had JIT support. And this clearly puts ARM at a disadvantage, performance at disadvantage to x86-64. So if we look at what's in a LuaJIT port, this explains the effort that's necessary to get the JIT working for ARM64. I'm not going to go over this completely, but it involves a large number of steps. And so this is the effort involved. This is what our engineers have been working on over the last 5 months. And we'll talk through some of these steps just a little bit later. So LEG, the Linaro Enterprise Group, has petitioned TCWG to help work on porting LuaJIT to ARM64. So we have some engineers in TCWG as well as engineers in LEG, and some industry friends and partners working on this effort. So to get access to the trees, you can find them on GitHub. And you can see the project development history here. It's a long list of commits over the last 5 months. So if we look at the phases of the LuaJIT project, it started with defining the project scope, identifying a minimum viable project, and then exposing and implementing IR translation hooks. And once those are completed, moving into continuous integration, eventually upstreaming and optimization. So currently, we are in phase 3. So as of this morning, all of the developers agreed that the LuaJIT ARM64 port is functionally complete. So that's a major milestone. Thank you. You can clap for me, but you're really clapping for these guys. So now we're in the phase of continuous integration and integration testing. So continuous integration is future commit level testing, verifying we're not regressing either ARM64 or x86-64. And the integration testing will be a CI loop that allows us to test LuaJIT mode with different applications, such as Nginx. Also part of phase 3 is a long tail of bug fixes and secondary feature fixes, preparation for upstreaming, some small optimizations. Phase 4 and phase 5 are grayed out here, but those are forthcoming. That is upstreaming and optimization itself. All right, so what will be done in phase 3? As I said, we have long tail of bug fixes, implementing the automation CI and integration. There were some lingering issues with LJGC64, but my understanding is we're very close to x86-64 here. This feature enables 64-bit address space in Lua, and that was just recently added to x86-64. I think it was 2 months ago, or 1.5, 2 months ago. So we're not too far behind x86-64 in this regard. So phase 2, this slide is here because when I wrote the slide deck, we were still in phase 2, but we have now completed phase 2, which is all the functionality and feature additions to LuaJIT to get the JIT working. So I won't go through all this, but this is just some of the challenges that the engineers had worked through. So when we look at what's left for the actual port, as you can see here, we are very nearly fully complete, and complete enough, as I said before, that the developers have declared that the port is functionally complete. So what does functional completeness mean? It means that the IR and translation hooks are complete. This is with the exception of the optimization hook, which will be added later. The entire test suite can execute to completion in isolation. We do have a garbage collector bug, but there are some known issues in the garbage collector, and I believe the same issue is found in x86-64. Charles can correct me if I'm wrong. No? Maybe? FFI translation hooks are complete. That allows the invocation of C library function calls. We have test suite parity between the JIT mode and interpreted mode. We do have currently a number of failures in the test suite compared to x86-64, but that number is actually smaller than this as far as I understand. And we will clean those up as we get ready to upstream the port. We are working on the CI mechanism. I'm not sure if we're going to use GitHub CI. I forgot to follow through on that one. And we are starting to look at Nginx support. So as far as the schedule is concerned, we did hit our original estimates right on. So I would like to congratulate the team on that. They did a fantastic job. We are hoping to complete the enablement of our test suite enablement by September. I have this slide wrong. And integration in CI by mid-October. And we need to verify that LJGC64 is at parity with x86-64. So that's the full status. So as far as we're concerned, we are functionally complete. We are just, as of like an hour ago, I did discuss the upstreaming effort with some of our partners. And how it's going to proceed is that we will do a short cleanup on the existing code base to unify all of the style, do some minor optimizations, and then our partner and our co-collaborators, RTRK, will start the upstreaming effort, and that's projected to take a few weeks. They're doing the upstreaming effort because they upstream the MIPS port, so they have a history with the maintainer. So we expect that over the next 3 months, we will polish and improve the port, and hopefully within a few months we can get something upstream. There is some concerns with upstreaming in that the community primary maintainer is interested in retiring from the project, so that could delay some upstreaming. All right, so Zheng Zhu has done a really interesting CI mechanism for us that I wanted to just sort of give you an idea of. So here's a static slide on it, but I'll actually take you to the actual tool itself as well. So this allows real-time testing of LuaJIT code and can do real-time performance comparisons of, let's see, what are the, Lua itself, so interpreted mode, LuaJIT 2.1, and then in interpreted mode, and then ARM64 JIT performance as well. All right, so I'm going to switch to the actual web page. So here we have the web page itself. So this is just the default view. Let's say I can run this application. Oh, I'm going to do it from here. And we get just some runtime information on the application itself here. We haven't actually benched anything in this case. I can show, whoops. I'll print hello world. Bear with me as I don't really know Lua. So likewise, we have information here showing that it's working in JIT mode, Lua interpreted mode, and ARM64 interpreted mode. And if I want to say, if I want to get benchmarking information, I would say bench world, and I can run that. And that shows us that there's no deltas because obviously the time frames, it's executing too quickly. But we have the availability of a number of pre-canned tests here that Zheng has provided us. And these are marked as bench, so these will show up with performance numbers. So here, for instance, this binary tree benchmark, we can see some performance improvements here. In JIT mode, we'll run through a few more and stack them up. And you'll see, as you see here, they start to stack up, so we can get sort of a live running total. Or not total, excuse me, just a trend across different benchmarks. So this is a tool that we'll use as well when we start our optimization efforts, so we can start to see where and how each of the modifications we make to LuaJIT for ARM64 will be realized in performance benefit. All right, so Zheng, was there anything else that you wanted to cover with regard to the demo? We do still have some time.
Actually, what I want to say that this demo is quite interesting, that we not only demonstrate the LuaJIT performance, it also demonstrates a lot of stuff in the enterprise area of ARC64. And this demo runs on web server, which also hosts on ARC64, obviously, and also we have a PHP server for based on that. It runs also on ARM64, and also this this web is hosted on Linaro Cloud, which is a virtual machine allocated for the demonstration. And also, we've put all the web stuffs inside a container. So this demonstration shows that most of the pieces of, I think, the ARM enterprise works, at least for this demo. Yeah, thank you.
All right, were there any questions on the status or where we're going next or what has been completed?
So is it possible to backport these changes on a released version of LuaJIT?
Charles? Charles's answer was no, not really. Do you care to elaborate as to why?
We very much dependent on the stuff that's been introduced in LuaJIT 2.1 release, say the only sensible thing to backport is the whole LuaJIT 2.1.
So the answer is that there were significant changes in LuaJIT 2.1 that are needed for the ARM64 JIT port. And I believe the current releases are based on LuaJIT 2.0. So it would require backporting everything into 2.1, from 2.1 into 2.0. I know some of the more experimental distributions are already starting to pick up 2.1, even though it's only in beta. And I believe this is related to the unknown nature of the future maintenance of LuaJIT. Are there other questions? Yes, Larry.
Yeah, Ryan, first, great job.
Thank you.
Together, we appreciate it. Do you kind of know, so next step is optimization. Do you have kind of order of magnitude sense of where we are from a x86 comparison or where we are now?
I think that's one of our next steps. Charles, any comments? Yeah, we haven't done any measurements as we literally just declared feature completion today, so we should have that information soon. We are syncing, the team will sync in the next month, and I should be able to get that information to you, Larry, at that point. We'll have a better idea of what our optimization targets are and where the upstreaming effort is. Let's see, further questions? Nope. All right, well, thank you for attending the presentation. I don't know if these slides are available in the session website, but I'll make sure they are. Oh, yes. Yeah. Yep. Let me find that for you. Yes. Oh, yes, he wanted the information on the GitHub. Location.
I was just saying these slides are not currently online. I was answering his question, that's all.
Yeah, okay. I will merge them. I will have them put up. It's because the only ones that got up online were the Xen slides. That was Wookiee on the little robot.
I don't get to say much.
Okay, well, that's all I had, so thank you for attending the presentation. And this, one last thing, the slides do have some resources here at the end, and there is an appendix which describes LuaJIT, trace compilation, and what a minimum viable program actually looks like in Lua to exercise the JIT. All right, thank you very much.